Ahoy, mate! Jump on the ship. I'll sail you to the ocean of probability. I'm Rutvik, and I'll be your captain.
So let's say you wanted to take part in one of these two giveaways. In one giveaway, there were 100 other people also participating, and in other giveaway, there were 10 other people participating. Which giveaway would you like to go for? Now you'll say, Ritvik, what kind of silly question is this? Of course I'll go for this giveaway. Now that, my friends, is probability at play, although subconsciously. Now before embarking into the huge ocean of probability, I like to acquaint you with some basic terms. Starting with probability is the extent to which an event is likely to occur. Or speaking in layman's terms, it is the ratio of number of things that can make you happy divided by total number of things that can happen. Random experiment. An experiment is said to be random when its outcomes cannot be predicted. When you roll a die, you never know what number you'll get. It's unpredictable. Sample space, the set of all possible outcomes. The sample space is called certain event, since whatever outcome occurs, it's guaranteed to be in S. The empty set phi is called impossible event. What is the probability that you will roll a number higher than 6 when you roll a die? That's right, 0. That's impossible. These are the common sample spaces that you'll be requiring in your numericals. Tossing one coin has two possibilities, one head, one tail. Similarly, tossing two coins has four possibilities. Similarly, tossing three coins. Now rolling a die, possibilities range from 1, 2, all the way up to 6. Rolling two dice is an interesting one. It ranges from 1, 1 all the way up to 1, 6 through 6, 6. You must have played cards. A deck of cards contains 52 cards. There are 13 of 4 suits: clubs, spades, diamonds, and hearts. The 13 cards are numbered 2 all the way up to 10, then Jack, Queen, King, and Ace. This is by hierarchy. The clubs and spades are black, while the diamonds are red. A face card is a Jack, Queen, or King. Events have unions, intersections, and complements. If E and F are two events, then E union F, that is the red, blue, and green portion, then that is the set of outcomes that are either in E or in F. Complements. E complement is the set of outcomes that are not in E, that is, outside this red and blue portion. E intersection F is the set of outcomes that are in both E and F, that is, this intersection part, that is blue in color. If two events cannot happen at the same time, then E intersection F is phi, and these events are said to be mutually exclusive. That is, if one happens, the other cannot happen. For example, while tossing a coin, you cannot get a tail if you are getting a head, and vice versa. Events of types. Equally likely events are the events that have an equal probability of occurrence. When you roll a die, you have equal probability of rolling either 1 or 2 or 3 or 4 or 5 or 6. Complementary events. Two outcomes of an event that are only possible outcomes. When you toss a coin, you either get a heads or tails. This either or are complementary events. Impossible event. An event that will not occur on any account. Rolling a number greater than 6 when you roll a die is an impossible event. Exhaustive events. Events whose union is the sample space because they completely fill the sample space. Mutually exclusive events. Two or more events are mutually exclusive if occurrence of one event prevents the occurrence of other. Rules of probability. The probability that event A will occur is equal to 1 minus the probability that event A will not occur. Rule of addition. The probability that event A or event B, or that is addition union, occurs is equal to the probability that event A plus the probability of event B minus the probability A intersection B. Important concepts that you will require for solving numericals related to die. Even numbers 2, 4, 6, the numbers divisible by 2 are even numbers. The others are odd numbers. Prime numbers, the numbers which have only two divisors, that is 1 and the number itself. Multiples of 2 and 3, 2, 4, 6 and 3, 6. Numerical. Read the question carefully. My explanation will follow. What do we have here? Sample space S is given 1, 2, 3 all the way up to 6. Number of outcomes 6. Let A be the event of obtaining a prime number. Outcomes 2, 3 and 5. Number of outcomes 3. Probability by a theoretical formula, number of outcomes in A divided by number of outcomes in S, that is 3 by 6, that is 0.5. Let B be the event of obtaining an even number. 2, 4, 6. Number 3. Probability is 3 by 6, that is 0.5. Let C be the event of obtaining a number greater than 2. Note that the number has to be greater than 2 and not 2. Therefore, the numbers are 3, 4, 5 and 6. Number 4. Probability 4 divided by 6, that is 0.667. Let D be the event of obtaining a number less than 1. When you roll a die, there is no chance that you will get a number less than 1. Therefore, there are no outcomes. Therefore, the probability is 0 by 6, that is 0. Read the question carefully. What do we have here? Number of good pens is 50. Number of defective pens is 3. The total number of pens, therefore, is 53. This is our sample space. What is the probability of drawing a good pen? Number of good pens divided by number of total pens. 50 by 53, 0.94. Read the question carefully. What do we have here? There are 5 days from Tuesday to Saturday, and there are 2 people visiting on these 5 days. Therefore, the sample space will be 5 into 5, that is 25. Let A be the event that both of them meet at the shop during their visit. In A, it will be Tuesday, all the way up to Saturday, because the days they both will visit would be the same. Number of outcomes 5. Probability 5 divided by 25, that is 0.2. Read the problem carefully. This one will be fun. What do we have here? Ram can have a birthday on any of the 365 days. Hence, there are 365 outcomes that are equally likely. Similarly, for Rahim, there can be 365 equally likely outcomes for his birthday as well. Therefore, number of outcomes in sample space is 365 into 365, that is 365 square. Let A be the event of both the friends having different birthdays. If Ram has his birthday on any one day out of 365, Rahim has his birthday on any day other than that day. That is 365 minus 1, 364. Hence, number of outcomes is 365 into 364. The probability is 0.997. Let B be the event that both the friends have same birthdays. Notice that this event is a complement of the earlier event. Hence, the probability will be 1 minus the probability of earlier event, that is 1 minus 0.997, that is 0.003. Read the question carefully. What do we have here? The total number of red kings in a deck of cards is 2. The total number of cards in a deck of cards is 52. Therefore, probability is 2 by 52, that is 0.038. So, I told you everything you had to know. Go. Win. Score.